Welcome to Light at Speed. In this video I will be explaining voltage drop. Hello and welcome to another edition of Light at Speed with remote controlled lighting and precision lighting. Voltage drop, put simply, is the voltage lost over a path on which current flows. Voltage drop occurs through any conductor, component, electrical connection or track on a circuit board. If electricity runs through a conductive material, no matter how great the quality of that conductor, the wire will resist the electron flow to some degree, reducing the circuit's voltage at that point. Usually this resistance can cause heat in the conductor, which adds to the resistance. Each electrical connection, which could be a solder joint or a screw terminal, will also have a resistance and a little voltage drop. It's more important to consider voltage drop if designing for low voltage LED systems with long power runs, because the voltage drop can be visible in the intensity of LEDs from the beginning of a circuit to the end. Voltage drop is proportional to conductor length. The shorter the wire, the less the voltage drop. Voltage drop is also proportional to the current running through the wire. For the same level of power, a higher voltage will have a lower current and would therefore experience less voltage drop. The same is also true for the diameter of the wire and its material. A larger diameter wire can handle more current and also has a lower resistance because there's more metal for the electrons to flow along. These electrons therefore have less resisting them, which causes less energy wasted as heat and less voltage drop. While voltage drop can be an issue to many electronic devices, in LED terms it's only really an issue for constant voltage systems like LED tapes or low voltage spotlight systems like 12 or 24 volt track. This is because their intensity levels are directly related to the incoming voltage level. It's quite common for long runs of LED tape to appear dimmer at one end than at the beginning. You can't simply use a thicker wire between the little individual LEDs on a tape because it's pre-built. But there are some tricks to combat this. Use shorter lengths of tape, each driven separately with its own driver. Use tape with a higher voltage, 24 instead of 12. Feed the tape from both ends, or feed the positive into one end of the tape and the negative into the other, as that unifies the circuit lengths. And of course, use thicker wire where you can. Constant current systems do not usually suffer this issue, as constant current drivers can adjust their output voltage level depending on the voltage drop they sense through the cables and the LEDs. They maintain the electrical current level requested by increasing the voltage a bit. The only time voltage drop is an issue with constant current is when the driver doesn't have enough extra voltage after powering the LEDs, often referred to as voltage headroom, to overcome that drop. So just make sure the driver is well specified. In conclusion then, always ask manufacturers for their advice, suggested cable thicknesses and max single run lengths. Minimize excessive low voltage cable runs and keep drivers as close to LED sources as you can. If long low voltage cable runs are unavoidable, use thick high quality cable and consider feeding the LED system from both ends. Thank you so much for watching. Be sure to like, share and subscribe, and I look forward to seeing you all again soon. Bye bye.